Hey, friends, it may seem counterintuitive, but chaos engineering is about breaking your applications for a good cause, resiliency. You can use Azure Chaos Studio to inject faults into your application to simulate real world problems. John Engel-Kemnetz is here to show me how you can test and monitor how your application responds to chaos today on Azure Friday. Hey, friends, it's Azure Friday, and it's chaos, absolute chaos. How are you, John?
I'm doing well. How are you, Scott?
I'm living the dream, and I am excited to know why chaos is the word of the day and why it's the best thing for my cloud application.
Yeah, for sure. So it comes out of this new practice called chaos engineering. It's really evolved over the past couple of years, and chaos engineering is the idea that you are going to proactively find failures in your applications by causing those failures in reality. And this is all in the best interest of improving the resilience of your application. So common things you might see somebody doing is injecting high stress into an application to see, hey, can my application scale up or handle a noisy neighbor? Or failing network to see, will you fail over to another region or another availability zone?
Interesting. So I want to say 20 plus years ago, kind of this, we didn't call it chaos engineering, but we would occasionally do things like unplug the SQL server. And then we'd see, well, can you lose a local cache? Or we'd have a write fail. And then we'd say, all right, well, we're going read only. And then we'd have a banner on the site that says, we're read only. Or you can't use the shopping cart, but the product catalog still works. So what I'm hearing you say is you want to throw a wrench into the works, but you don't want the entire car to collapse and fall apart. Like it should still do something.
Exactly. And I think with chaos engineering in particular, they found this very good way to structure how you do that sort of chaotic event,
Hmm.
which is always kind of starting with, let's understand first our steady state, our healthy state for the application, make sure we're looking at that in our data, then discover a hypothesis, formulate that, come up with an experiment to validate or invalidate, look at the results, and then make an improvement based off the results. So it's very kind of use the scientific method to make sure that you're not just willy-nilly unplugging things.
Interesting. So what we were doing many years ago was willy-nilly, like, hey, go unplug that, see what happens. There was no formality to it. What you're describing is like when security turned into threat analysis and assessment, you're doing a chaos assessment. You're saying like, hey,
Yeah.
and then applying the scientific method. I like that. So it sounds like chaos engineering isn't just randomly doing stuff. It's a formal way of thinking about your systems.
Right. And in fact, one formal way of thinking about your system is what happens when there is absolute chaos, right? But that certainly isn't the only applicability of chaos engineering is, the complete havoc on a system. It can be more structured, we want to make sure that this one failure mode is accommodated for in our architecture.
And I assume you could potentially sort your failure modes by impact and say, we can't handle all things. It's going to be times the site's going to go down. DNS happens. It's always DNS. But we could go and sort it, figure out the long tail, and say, we're going to handle chaos from here to the left.
Yeah, totally. And I think, especially as a cloud provider, right, on Azure, what we care a lot about is helping our customers to make sure that they can recover from any sort of Azure side failure as well, right? So, should there be any impact or an outage, we want to make sure customers can replicate that on their own and avoid impact should it ever happen again in the future.
Very cool. So where do I get started? How do I do this?
Yeah, so let's go over to the Azure portal and just get started. What I've done is I have a sample application I'm using that runs on Kubernetes, and it runs in AKS. It has a website that we're kind of regularly interacting with, and a couple of other services, all in their own pods within a namespace that's called the backend development namespace. This connects up to a set of Cosmos DB instances that are located, their primary write region is in East US, and they have a backup read region, all of them, that's in West US too. So what we'd like to do is say, hey, what happens if there's a major failure in this application? Will it stand up? Will availability remain high? So to do that, we're just going to jump over to Chaos Studio in the Azure portal. So you can search for it using the search bar, or it's in my recently used services. I can just jump in here. And if I were doing this completely fresh, the first thing I do is come in and onboard the AKS cluster, those Cosmos DB instances that I want to target for failure, for fault injection. I've already done that in this case, so we can just jump straight ahead into building our first experiment.
Mm-hmm.
So an experiment is an Azure resource. That means you can develop it as an Azure template. You can use Project Bicep, all the familiar things you're doing to deploy your infrastructure as code. You can apply that to deployment of your chaos tests. So in my case, I'm just going to pick a resource group in a subscription and give this a nice name like Azure Friday. I then move into my experiment designer, and this is where I'm actually formulating what are the specific failures that I want to cause in my resources, and kind of when do I want those failures to occur, so I can build up what I would call like a broader scenario of failures. Now, this can be really powerful because you can run actions in parallel, run things that happen in sequence, have a break in between, like a time delay. So you can really build up what a real life outage would have looked like and replicate that in the experiment designer. Um, I'll just do a really quick example here to show you how this all works. Steps, these are what execute sequentially, and each step can have one or more branches that will run in parallel. So let's say I just wanted to come in, add a fault, and say, hey, I want to shut down a virtual machine or a set of virtual machines uh, that are running an application for a period of time. So I've got that VM shutdown fault. You can see the full list of faults here, and our fault library is in our documentation, but we strive to cover the most common outage scenarios that customers see. So virtual machine shutdown, I'm going to give it a duration for how long I'd like the VM to stay shut down. And then I have different parameters based on the fault that I'm selecting. So in this case, I want to do an abrupt shutdown. That means it is the equivalent of that unplug it scenario you had. There's no time for an application to save state, for the OS to safely shut down. Boom, it's dead.
So, if I may, and
Yeah.
this might be a weird question, but is this real? Like, are you really shutting it down? And if you did, what if your application wasn't very resilient? What if by shutting it down you broke something? So, and how do you make sure you don't actually run chaos in production?
Yeah, that's a great question. And in fact, I wouldn't even say it's how do you not run chaos in production. It's how do you control when you're
Well,
running
controlled
chaos in
chaos. Yes,
production. Yeah.
exactly. Like I want to
Um,
run it, but I don't want to get in trouble and be fired because I pushed yes in Chaos Studio.
Exactly. Yeah. So, first thing to answer your first question, this is not a simulator. We are injecting faults. They're real.
Mm,
When I shut down that VM, it's shut down. It isn't making it look like we shut down a VM. What you're simulating is a real world outage, right?
gotcha.
But the failures themselves are real things. And so that does mean you need to be safe. We do a couple of things in Chaos Studio to help with this. The first is all about permissions. Who has access to create an experiment and run an experiment? And then, even beyond that, when you onboard a resource to Chaos Studio, you can be really specific about which resources are onboarded and which faults are allowed for a given resource. So I can say, hey, I'm okay with virtual machine, high memory, and high CPU failures, but I never want a virtual machine shutdown to be able to happen because that's more
Gotcha.
destructive, right?
Gotcha.
Um, and then the final thing is, with our experiments, you can always stop them and roll back the state of fault injection if something starts to go haywire, if things look way worse than you thought they would. So all of those safety measures are just built into how you work with the product.
Cool.
So that's just a simple example. I'd add a virtual machine shutdown. Let's just say that's the only one that I wanted to add. I'd then go to review and create, and I could create this experiment. Now you'll notice, to your point about safety, there's a little banner here indicating that before I can run the experiment, I have to give my resources or grant the experiment permission to my resources. So the experiment itself will get a system assigned managed identity in my Active Directory tenant, and that identity has to have the appropriate access to each resource that it's going to impact. So
Right.
there's even that additional layer.
And I mean, I'm going to make an assumption here and a guess, and you tell me if I'm right. Because we're using, you're using user identities and service principals, and this is actually a resource. All of this is auditable. So if anyone is worried that someone could use this for nefarious reasons, the audit log is going to show you everything that's going on.
Exactly. So the activity log will always have any operation we perform with the experiment name as the identity that performed the action.
Cool.
Um, so what I did for this application is I've got an experiment all set up, and I'll just get it started here while I show you a little bit of what's in here. So what I'm doing is first, I have two different branches, so two different things that are happening in parallel here. The first is an AKS pod chaos activity. And what we do is we just use a utility from the Cloud Native Compute Foundation called Chaos Mesh. It's an open source fault injection tool for Kubernetes. And we just leverage that right out of the box for doing fault injection on AKS. Rather than trying to boil the ocean and do something different, we use what we heard customers are already using. So what I've done is I've just set this up to do a pod failure action over the course of 20 minutes, continuously fail all pods that are in one specific namespace. And that's the namespace running my application.
And are this JSON spec, those parameters, is that a standard thing? Like, how do I know that that's the way to pass in parameters?
Yeah, so this is just, we're just using Chaos Mesh specification. Now, Chaos Mesh does use YAML, and so you have to convert it to JSON just to go from the kind of Kubernetes world where you're typically using YAML to the Azure Resource Manager world where we use JSON,
Gotcha.
right?
I
But
see.
it's just a conversion of the Chaos Mesh spec that you would have written in YAML for a Chaos Mesh experiment.
And I assume that my team or my large enterprise could write my own faults. We could share them with other organizations. They could be faults that are specific to our org. In this case, you found one on the shelf somewhere. I could make my own.
Yeah, you could adapt the Chaos Mesh spec in terms of more broad, like custom faults. Definitely something on our roadmap. We've heard a lot
Cool.
about this is, can we, just come up with our own faults? Right now, they're a little bit more kind of restricted. We say which are the faults that are available
Mhm.
to curate a list that we know will work well, but it is on our roadmap to accommodate kind of any fault you might come up with.
Very cool.
Yeah. So in my experiment, I also have a Cosmos DB failover action. This one's going to take those 3 Cosmos DB instances and it's going to attempt to fail it so that the write region, which was East US, gets demoted to be a read region, and the read region, West US 2, gets promoted to be that write region. So I started it. I can see it's moved into running state here, and I can always click into details to see how it's going. So I can see that my first step is running, and on AKS as well as on my Kubernetes on my Cosmos DB clusters, the fault is now running. So let's go and see if it really is. First, I'll go back to my Kubernetes cluster. We can see before I do a refresh that everything's ready and healthy in terms of the pods in this namespace. Clicking refresh, oh no, everything's moved into this state where there's warnings. And if I were to click in, I'd see that the containers are cycling between errors and trying to recover, but Chaos Mesh is continuously failing those pods. On the Cosmos DB side, I started with my write region as East US. Let's give it a refresh. All of a sudden, my write region is West US 2 for all of these, so that failover has happened successfully. We'll stay with West US 2 as the write region until the end of the experiment, which is when we revert all of that state. So final thing I would look at is just, I've got an App Insights component all set up for me to monitor this. And this is so that I can see availability and history and understand the impact of the chaos I caused. And sure enough, if I look into availability here, I have just a ping test on the website. Availability is all of a sudden in the last couple of minutes here dropped down to 0%. And that's because that ping test is getting a 404, and it's getting that because those pods running the website are now down. So we can see, sure enough, that chaos experiment I set up is having impact. It's breaking something. My next step is going to be to say, okay, where can we make an improvement? Should we add a load balancer in front? Should we attempt to find a way to redirect traffic to another region? What might be that mitigation that prevents us from seeing 0% availability should we have this sort of major failure happening?
Right. And then the engineering team and the architectural team could say, this is a thing that we could solve with an Azure feature, or this is a thing that we could solve with code, or this is a thing that we could solve
Exactly.
with software-based networking or a CDN or whatever.
Right.
But you don't know until you cause the chaos, and then you
Yeah,
know.
totally. Uh-huh.
Very cool. So where can I get started? Do I just go and make a new resource now?
Yeah, sure. So you can get started. I'd recommend going to aka.ms/chaos studio get started. That's just an easy example starting point in our documentation, but feel free to just go to the portal and search for Chaos Studio and start building your first experiment.
Very cool. And what's the pricing? Do I have this already? Is it per experiment? Is it how often they run?
Yeah, so the pricing it will be based off of what we call the target action minute, and that's based off of the duration of the actions you have per target resource. So there's a charge per minute per target resource, but the service is free up until April.
Very cool. So the service is free till April. So go and cause some chaos, and then it'll be a nice, thoughtful consumption-based model, which makes a lot of sense.
Mhm.
Fantastic. Well, I am learning all about how to cause chaos and make my applications just that much better today on Azure Friday. Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.